Coming up on the FRC Open Alliance Show, 4322 Clockwork is back to talk more about some of their progress they've been working on, showcasing some live demos right away, so keep an eye out for that. And they'll be talking about some changes they got to be making. They're running a little bit overweight, so some of the weight-saving measures that they're going to be utilizing. Also, how all their vision assistant alignment is going to come into play and work together, as well as a couple of their other features that they're trying to get together in their robot as they compete for Week 3. So Clockwork's been looking really good. Let's learn more about their progress coming up here on the Open Alliance Show. Let's welcome back 4322 Clockwork coming in from California. It's so great to have you back on. Your progress has been awesome. All the different tests you've been posting on your build blog have been great. And I know we're going to be talking about that operator board later on too, which I'm very excited about. So guys, why don't you introduce yourselves, let us know what you do on the team, and let's hop right into some cool robot demos.
Yeah, for sure. So my name is Drish, and I do the software and fabrication on this team.
I am Michael, and I do design and build.
Let's get started with the robot demo. So before we actually do our demo, let's talk a little bit about our design choices on our, let's start with our elevator. So what we actually have on here is we have two constant force springs for our elevator, which is supposed to kind of act as a counterbalance. The reason why we implemented this versus like without a constant force spring that we had initially was we learned from a 2024 off season that when we move the elevator up and down, it causes the voltage to drop a lot. And like combine that with like your things like your robot auto rotating and your like feeder running, like that can cause you to go to brownout territory. So what we actually did was we implemented these constant force springs so that it kind of reduces the amount of voltage draw for your motor, reduces the power for it, and would make us more reliable.
So now we will be going into our demonstration of our robot. We will be first testing L2. So this was one of the issues we talked about earlier, where sometimes when the coral is intaked at an angle, it sometimes gets stuck within the end effector. Sometimes we wiggle it, and it might fix the problem, but that is a problem we're still fixing. Probably changing the wheel configurations is that would be our current plan.
Go ahead and take that.
Okay. Elevator rise. Turn up to L2. Oh, L1. Yep. And there's L2. So, and now we will be testing L3. Beautiful.
For your elevator design, is that all custom work on it? Are you utilizing any COTS on it? What's kind of the design process for that?
Yeah, so we kind of had so with our garage mindset we mentioned last time, in our 2024 off season we had those bearing blocks from our bot, which was called Toast, and right, following the garage mindset, we use anything that we can get, something we already have. We don't order unless we have to. So yeah, with that mindset, we kind of just reused our bearing blocks, and yeah, it's looking really good.
Yeah, very effective. I agree for that. Yeah, let's talk algae.
So this is our algae flipper. We just made a little bit of configuration for to use mechanism wheels instead of the original cat tongue tape, because we thought it might save us a lot of time for scoring, because we can de-score algae and score coral at the same time. So we will demonstrate that right now. Yep. Perfect. So a problem we are currently having with this configuration that we're still testing is that the belts down at the motor, the pinion is sometimes skipping the belts, which is posing a little bit of an issue, and we're looking to fix that soon. Yes. And yeah. So we also have a flipper logic to prevent our flipper when scoring at the reef for the flipper to safely score and not be able to hit the pegs. So we will demonstrate the logic right now. Yep, so the safety logic has been run through many tests, and it seems to be really successful. Yep. Okay, Yeah.
Let's go ahead and show the captain tape side as well without the floater. See where the column is without it.
Yep. So now we will be showcasing the side of the Kapton tape, our original design. Okay, there we go. Yeah, so with the Kapton tape design, we are unable to take the LJ off and score at the same time, because with the mechanism wheels, it allows us to slide the LJ in a direction off of the reef. So this is one of the cons of our Kapton tape, and we're aiming to improve that with mechanism wheels. Yep. And now let's head over to our upgrade paths. Okay, so within the past few weeks, we have been building the robot, of course, and we have also been working on this new mechanism for the LJ floor intake. So basically, we just have the plates, two plates mounted to the superstructure, taken inspiration from 6328's intake, and also Robotics. We originally wanted to mount this on the swerve because we kind of didn't have enough space and we wanted as much security as possible, but because of a battery concern, because our battery is placed so right next to the drive base, we are unable to have the live axle to be this low. So we had to raise the live axle in order to access the battery, which also caused different geometry issues, which we were able to fix. And so now we're forced to kind of mount this to the superstructure. So with our LJ intake, we have a light axle powered by a Kraken motor and another Kraken to power on the arm to power the rollers on top. So basically, we have a polycarb kind of Lexan on the back to act as kind of a hook or catch that will allow us to intake and keep the LJ within our robot and eject as we wish. So a few problems that we ran into was, one, the weight constraint. So just a week ago, we measured our robot before we have even put on the LJ mechanism, which we still haven't. Is that we ran into a weight issue. So our robot was weighed about 122 pounds without farm reserve battery, which kind of exceeds the weight limit. So we've been working to cut some weight on that. We've been replacing lots of tubes from like 1/8 to 1/16, and we've been replacing a lot of aluminum to 3D printed parts. And so specifically for this LJ intake here, because of that weight restraint, we kind of have to make all the parts into polycarb, to be cut out of polycarb, and we think that it would work fine. Yes.
Mm-hmm. Another thing about the weight is that we're actually going to change our belly pan to a polycarb one, which would save about 13 pounds, and that would give us a weight margin to put on this intake, hopefully, along with our other weight optimizations. So kind of going back to our garage mindset, like this season, like we've built our robot and got scoring by week 5, which is like the fastest we've ever done before. And the reason for that, a big part of it, is because of our manufacturing. So in previous years, our manufacturing was pretty slowed down. We didn't have the parts to assemble it in time. So we actually did this season was we looked to our local suppliers. We just see, okay, what kind of lead times do they have? And we found a really gracious supplier who's able to give us all these parts in really like really short periods of time. And that pretty much allowed us to build this robot. And now it actually lets us to go into other things like software automation. So our plan for software automation these coming few weeks is we want to get our single tag auto alignment done. And once we get that done, then we can go off onto autos and have this a consistent 3 coral auto. So all of that is because we were able to finish this robot in 5 weeks and have basically a minimum viable product. And that has helped us all tremendously this season. And we can't wait to see what else this robot can do.
I want to go back real quick, if you don't mind, on your algae intake for what you're using on that. So, just so I understand the process correctly on it, so you're essentially looking at not taking the algae off the reef and then letting it bounce first, and then intaking it in. Is that correct?
Yes.
So
That is the plan. Yeah.
yeah, what I was going to ask is just like, from that, how does that kind of factor into your match wise? Like, are you going to let it rest first before you try to go for it and then score coral in the meantime? How does that kind of work into like a full match cycle for you?
So we actually toyed with, we don't have an image, but we kind of toyed with these kind of like different kind of cycles where it's like this triangle cycle where you go score one, then you go into your processor and come back to a coral's loading station. We're thinking maybe something like you kind of go to a coral, you descore the algae, score the coral, and then you pick it up from the ground, score it into a processor, and come back into your loading station. So we're kind of thinking something like cycles like that. We haven't thought about it too much, but that's kind of the thing that we're going for.
The other thing I want to follow up with you on is in regards to some of your weight reductions you're doing, like moving to polycarb for that intake as well too. Now, by doing that, you're probably adding a lot more compliance, I'm guessing, right? In terms of the moving around in the field. Do you think that will impact it all, or is that kind of just something that will just work out? I mean, we've seen a lot of compliant intakes out there, but does that change on how some of your strategy works or anything like that?
I think our strategy would be the same. I don't think the algae intake will be posed to a lot of threat this season specifically, because this season how robots are technically functioning at half a field, and we won't see too much in other line spot movements. So yeah.
No, that's a really good point
have
on there, right? You might not have to deal with nearly as much bumping as we've seen in maybe like last year or even the year before, that sort of thing. So yeah, that makes sense.
Yeah, concern we do have though is because right now we have our belly pan as steel, and by switching to polycarb, we're thinking that it probably is going to increase our center of gravity, and that could cause tippiness. So we were thinking about many different solutions to this. Ideally, with our algae intake on and max weighting our bumpers, those would probably help a lot in reducing our CG. And if need be, we're thinking about having some kind of traction control logic for our swerve, so to stop those really fast accelerations and side movements that would cause it to tip.
So what are a couple other things you want to showcase or talk about? Yeah, we got to talk about that, by the way. I love seeing that on your Cheap Delphi post.
Yeah, so this is our button board right here. You can see in the back, it's kind of wired. So right here, what we have is we have all of the scoring locations for our reef. A big part of our automation that we want to do this year is we want to be able to click on these buttons and say, okay, when you click the button, you say, okay, what tag are you trying to look at specifically, and what scoring position you want to go to. And so what it does is it tells the robot's information, and just with one button press of the driver and the operator pressing this, it kind of can say, okay, let the swerve auto rotate to whatever the angle of this face is, and then also scan for the tag. And when you do see the tag on the camera, you just go up and immediately line to this position. This kind of goes to our automation where it's like we just want really fast, reliable automation, one button solutions that would just be really intuitive. So this kind of would help achieve that goal. And then over here we have these L1 to L3 buttons. We're potentially, adding an L4 maybe. But we have these L1 to L3 buttons over here to kind of set the scoring presets. And over here you can see they have a bunch of different buttons, which I'm sure, Michael, you want to talk about.
Yeah. So for these buttons over here, these 6 arcade buttons, for now they're just temporarily there. They are not wired or anything, just in case we need any extra measures to be taken during competitions, which we definitely have needed in the past. And then so we have switches here. I believe we only have a few of them that we are going to use, or maybe none during, we're going to use a few during the competition. And they're going to be for the algae flipper toggle, and another one probably for algae intake toggle. Yes.
And also we could select with these ones over here, which we know are covered. It would be nice to set them with coast mode, setting your elevators, you can move it up and down pretty easily. So that's kind of we're just kind of having the flexibility, because with these controls actually in the back over here, these were inspired from 6328's 2024 button board, and they have 12 slots each, and we're using 2 of them. So we're saying 24 slots, 24 buttons. Let's just send it with that.
So walk me through how the actual process works in terms of marrying this with your vision assistant alignment, right? So the
Mhm.
operator presses, the level and where you want to go. At what point is the robot essentially taking over? Is it running like autonomous? Like, where do you have to drive up to, at least in what your current plan is, in order to get everything to start automating?
Yeah, so our current plan is with our cameras, once the operator presses the scoring preset and the location they want to score, it tells so then that's communicated to your robot, and when the driver presses like the score button, what it does is they'll be able to drive while pressing this button, and then when the vision sees that the camera is detected in their field of view, then what we do is the vision pretty much takes over from the robot. And we want to have smooth, seamless transition because in 2023 we kind of dabbled with auto alignment to the single substation. It didn't work as well because a big part of it was because the transition was really clunky. So this year we want to smoothen out that transition so it's like you don't even know when the software is taken over from the driver. So drivers kind of just drive over to that location in the general area, and then when the camera sees it, it'll kind of take over and align, and then it'll move the elevator up and score it, and then it's good.
Well, Clockwork, before we let you go, you're competing week 3 is your first one, so you got a little bit of time still until your first one. Is that, of course, will go by quite quickly. But anything else you want to wrap up with, or tell us about some future plans as you lead up to your first event?
I think the main thing would be like the fixing the issues that we saw today, and then also definitely getting our automation down. We definitely want to have our automation and have an auto that can do 3 or 4 L3s. So we're really hoping for that, and yeah.
Well, we wish you best of luck all the way through. Thanks again for coming on to tell us more about your progress and showcase it too. It's always great to see some awesome demos as well too. So best of luck, and can't wait to see how you do at your first event. Thanks a lot.
Thank
Thank
you.
you.